Servus aus Berlin. Hi, my name is Matthias Rillig, and today I'd like to talk about microplastic having positive and negative effects. Now, it's confusing when you tell a room of people that when you add microplastic to soil, positive things can happen. Positive in terms of a variable that you have measured increasing in value. For example, you add microplastic to soil. Very often there are changes in the soil as a consequence of that. For example, decreased bulk density that allow plant roots maybe to grow better in that soil. And as a consequence, we have frequently, but not always, observed increases in plant biomass and generally plant performance when you have added microplastic. This is puzzling at first sight because you think this is something that should not be in the soil. It's bad. Microplastic pollution is clearly undesirable. It doesn't belong there. So how come it can have positive effects? This is really weird. When you think about it, there is many other factors like that have a bad connotation. They are undesirable ecological changes, but they also have actually initially positive effects on the target organisms concerned. Take elevated CO2. Elevated CO2 on plants usually has positive plant growth promoting effects because it removes the limitation of one of the carbon fixing enzymes in plants. They just work better with higher concentrations of CO2. So is CO2, when it's higher in the atmosphere, good? No, for sure, it's not good. But it has this initial positive effect on a target organism. Now let me explain to you why that can be interpreted in a negative light. First of all, quite simply, it doesn't matter what the effect size direction is. It's a change in a system that wouldn't have occurred if that factor was absent. And that in itself can be reason enough to attribute a negative connotation to this change because it is a change. That's the first point. The second point is, while there may be initial positive effects on a target organism that you have examined, it doesn't mean that all the parameters in the ecosystem, for example, respond positively to this factor. For example, you can have initial positive effects on plant growth that we have observed, but we have also observed a change in a negative change in soil aggregation quite frequently, so that soil aggregate stability decreases. This means that some components of the parameter space or the collection of variables that you could measure have responded in fact positively, but others haven't. So the picture is actually quite more complicated than you would have if you just focused on one particular variable. That's the second point. There may be positive effects, but they may not be pervasive throughout the entire system that you're looking at. And there is a third point. The third point is there can be these positive effects on particular target organism in terms of plant growth, for example, as we've seen with plants and microplastic. However, that doesn't mean that is a positive effect because this improved plant growth can lead to changes at another level of the ecological hierarchy that you would interpret as a deviation from the way things should be. And the clearest example of that is that if you have a positive effect on individual plants, plants don't exist out there as individuals. They're always a member of a plant community, an assemblage of plants of different species. Now, when you have a positive effect on a target organism, such as a plant, it is super unlikely that all the plants in that community respond in the same proportional way to that factor. That can almost be excluded. Because, plants have different lifestyles, different physiologies, different ecologies, and they occur together in this community, but it is super unlikely that they respond exactly in the same positive way to a particular factor. Which means, yes, there can be positive effects on plant growth at the level of the individual plant in your experiment. But if you look at the level of the plant community, it's very likely to lead to a shift in the relative abundance of different plant species in that community. In other words, plant community composition can change. And so definitely this change in plant community composition can be interpreted in a negative light because it is a deviation from the normal state of that particular ecosystem and community. And we have recently shown that also to be the case for plant community composition. There were individually positive effects on plants, and they did translate to a shift in plant community composition at that level of the hierarchy, just because not all plants were able to profit in the same way from that factor, leading to shifts in relative abundances in that community. And that can be interpreted in a negative light. So while it is initially confusing to say, well, this factor that really is an undesirable factor has these positive effects on a particular measured response, there's various ways how these positive effects can translate into something in fact undesirable. Hi there! If you like this video, don't forget to click like down there, and also remember to subscribe to the channel, and feel free to leave comments. See ya!